Hello everyone, welcome back. In today's video, we are going to solve one of the most popular coding interview questions asked by companies like Amazon, Microsoft, Google, and many others. At first glance, this problem looks like a dynamic programming problem, and many people immediately memorize the formula. But in this video, we are not going to memorize anything. Instead, we are going to understand why the solution works. Once you understand the logic, you will never have to memorize this problem again. Let's first understand the problem. Imagine you are standing at the bottom of a staircase. Your goal is to reach the top. But there is one rule. Every time you move, you can either climb one step or two steps, nothing else. The question is, how many different ways can you reach the top? Notice that we are not trying to find the shortest path. We are simply counting all possible valid ways to reach at the top of staircase. Let's start with a very small example. Suppose there are only two stairs. How can we reach the top? The first way is taking one step and then another step. The second way is taking two steps directly. So the answer is 2. Very simple. Now, let's increase the staircase to 3 steps. Let's write every possibility. One step, one step, one step. That's one way to reach at the top. You take only one step at a time. Now, the second way is one step followed by two steps. Now you reach at the top. The third way is you take first two steps followed by one step. That's all. So, for all three stairs, we have three different ways. Still easy. Let's try one more example. This time we have four stairs. Again, let's list every possible combination. After listing them, we get five different ways. Now, I want you to stop looking at the combinations. Instead, look only at the answers. For one stair, answer is one way. For two stairs, answer is two. For three stairs, answer is three. And for four stairs, answer is five. Does this sequence look familiar to you? At this point, many people immediately think this looks like Fibonacci. And yes, it does. But don't memorize that. Interviewers don't want memorization, they want your reasoning. So let's understand why this pattern appears. This is the biggest trick in dynamic programming. Most beginners think like this: I'm standing at step 1. What should I do next? Now, instead, let's think backwards. Suppose our destination is step 5. Don't ask how do I go from step 1 to step 5. Ask how could I have arrived at step 5. That small change makes the entire problem much easier. If I am standing on step 5, where could I have come from? There are only two possibilities. Either I was on step 4, then I would have taken one step and reach at step 5, or I was on step 3 and took two steps at a time to reach at step 5. Now, can I come from step 2? No, that would require jumping 3 steps, which is not allowed. Can I come from step 1? Again, no. So there are only two valid possibilities. Either I was standing on step 3 or step 4. This observation is the key to solving the problem. Now, let's understand the most important part of this problem. Until now, we were actually listing all the possible combinations. But imagine that instead of 5 stairs, I have 20 or 30 stairs. Do I really want to sit and list every possible combination? Obviously, no. So, we need a smarter way to count the possibilities. Let's say my destination is step 5. I already know that there are 5 different ways to reach step 4. I don't even need to know exactly what those 5 ways are. I only need to know that there are 5 of them. Now think about what happens to each of those 5 ways. Once I have reached step 4, there is only one way to reach step 5 from there. I simply take one more step. So those 5 existing ways give me 5 ways to reach step 5. But remember, I can also reach step 5 by coming from step 3. And let's say there are 3 different ways to reach step 3. From each of those 3 ways, I can take a 2-step jump and reach step 5. So these give me another 3 ways. So let's put these two groups together. From step 4, I have 5 ways. From step 3, I have 3 ways. Therefore, the total number of ways to reach step 5 is 5 plus 3, 8. This is where I would spend extra time because beginners often wonder, why are we adding? We are adding because there are completely different group of possibilities. Group 1 ends with a one-step move from step 4. Group 2 ends with a two-step move from step 3. A particular path cannot belong to both groups. So there is no duplication. Therefore, we can safely add them. Imagine I have 5 ways to reach a particular place by bus and 3 ways by train. If the bus routes and train routes are separate, I have 5 plus 3 equal to 8 possible routes. The same idea is happening here. And this is where our formula comes from. We don't need to memorize the formula. We can derive it ourselves. We will see in next slide. And now we finally have our formula. To reach any stair, we need the number of ways to reach the previous stair plus the number of ways to reach 2 stairs before. This works for every staircase, not just 5. This is the recurrence relation. Now, converting the formula into code becomes very easy. If there are 1 or 2 stairs, we already know the answer. Otherwise, we simply calculate the answer for n minus 1. Calculate the answer for n minus 2 and add them together. This is recursion, very elegant, but there is a problem. Look carefully. How many times are we solving step 3? Twice. Step 2? 3 times. We are solving the same problem again and again. This repeated work makes recursion very slow. That's why recursion has exponential time complexity. Instead of solving the same problem repeatedly, let's save every answer. First, calculate the answer for 1 stair, then 2 stairs, then use those answers to calculate 3, then 4, then 5. This is dynamic programming. Calculate once, reuse forever. Now, observe something interesting. To calculate the next answer, do we need all previous answers? No, we only need the previous 2. So instead of storing an entire array, we just store 2 variables. This reduces our space complexity from O of n to O of 1. This is the solution I would write in an interview. It is simple, efficient, easy to explain. Time complexity is O of n, space complexity is O of 1. This is exactly what most interviewers expect. Whenever you solve a dynamic programming problem, don't start by writing code. Start by asking, how could I have reached this state? Once you answer that question, the recurrence relation almost writes itself. That's the real skill interviewers are looking for. If you found this explanation helpful, don't forget to like the video, subscribe to the channel, and let me know in the comments which interview problem you would like me to solve next. See you in the next video.